So for our second example here, we're going to go ahead and look at wine dispensing machines. I'll wait. Go ahead. Go look them up. It's a real thing. Okay, welcome back. Now let's go ahead and talk about what we're testing here. So what happened is someone went to one of these machines and took 4 observations, had it pour 4 glasses, and what they noticed is it wasn't quite what the machine was advertising. So we want to know, can we conclude that the machine is giving out less wine than it should be? We want to reach a conclusion, which means we're doing a hypothesis test. I'm measuring a quantitative variable, so I know I want to do a mean. It also says average in here. First step will be to go ahead and list everything I want to use. I will list X bar, which is 5.065. I will list S, which is 0.09. I'll list N, which is 4, which means my degrees of freedom is 3, and mu naught. Mu naught is what I want to compare to, and I'm trying to compare the actual measurements with the supposed measurements of 5.1 ounces. Having done that, we're on to step 2. In step 2, the first thing we do is list our null hypothesis. This is what we're assuming. Well, we're given the machine benefit of the doubt. We're going to assume it gives 5.1 ounces on average. Not what we're trying to prove, though. Our alternative hypothesis is we want to show it's giving less than 5.1. So I'll have less than 5.1. Step 3 is my test statistic. During this step, we need to calculate SE, and then we also need to calculate T. At this point, you can go ahead and pause the video, try and calculate it on your own. One thing to observe, though, is that because our observations were given to us down to the 3rd decimal place, let's go ahead and keep 3 decimal places for this one. For most mean problems, like on your homework or on a test or on a quiz, we're going to keep 2. For this example, let's go ahead and keep 3. Now, in this case, SE is going to be right around 0.045, and T should give us right around negative 0.778 if we round. Notice that's a pretty small t-score, and it's a pretty small t-score because the difference in between what actually happened and what we expect is pretty small. Okay, to do step 4, we need our p-value, and to find our p-value, we're going to have to go ahead and get our table back in here. Keep in mind that the only information we need to calculate our p-value is exactly what our t-score is, which in this case, it's negative 0.778. To make sure our alternative is one-sided, or that we'll have to double if it's two-sided, in this case less than, so one side, and then also our degrees of freedom. Our degrees of freedom is 3, so first thing I'm going to do is go ahead and highlight the degrees of freedom 3 row. Then I'm going to go ahead and find what's closest to my t-score. Notice my t-score is negative 0.778, but because the table is symmetric anyway, I can just go ahead and ignore the negative. I'll pay attention to only the fact that it's 0.778. Looking at the table, we find what's closest to 0.778. 0.765 is a little bit below it. 0.978 is a little bit above it. So we'll go ahead and trace both of those up to the top, here and here. Gives me 0.25 and 0.20. I don't have to double it because it's only a one-sided. My p-value then will be in between those two because my t is in between those two. Put in my greater than symbols, going left to right. And this shows me that my p-value is somewhere between 25 and 20%. Let's go ahead and get rid of the t-table now and move on to the 5th step. The 5th step is our conclusion. And to reach our conclusion, we always compare our p-value to our significance level of 0.05. Our p-value is in between 0.25 and 0.2. In fact, if you look at it, I can tell my p-value is bigger than 20%, and if my p-value is bigger than 20%, it sure as heck is bigger than 5%. Based on this, then, I can say, well, we fail to reject. There's a 20% chance this would happen if my assumption is true, so I'm going to fail to reject H naught. That means there is not enough evidence to suggest, and going back to what I was trying to prove here, that the machine is giving out less wine than it should be. Now, something to pay attention to here, the two examples we've done in the videos have both been less than or greater than. That is one-sided. If we had a two-sided, all we do is double that value we found here. Other than that, 5 steps are the same.